All right, so today's recap FRQ is going to be from 2018, number 2, dealing with particle motion with an emphasis on using your calculator. So anything question 1 or 2 would be a calculator active one. We've actually done this one in class before. It was one of the stations we did a while back, but we never really took a lot of time to go over it. So we're going to go through and try this one again. So a particle moves along the x-axis with a velocity here. Looks like a pretty messy function. Sine is involved, so we're definitely going to want to be in radian mode. And this function is applicable between time 0 and 3.5. We know that the particle starts at time t equals 0, 5 miles to the left of whatever we're calling home. So maybe home is a flagpole or home is the apartment building, whatever that might be. So to get started on a question like this, I'm going to first go to my y1 and I'm going to store this function. Well, actually, first I'm going to make sure I'm in radian mode, which I am. So I'm going to store this function as 10 sine of 0.4 x squared divided by, keeping all of that in the denominator, x squared minus x plus 3. Just so that from here on out I can reference this in my calculator as y1. I'm also going to change my window in case I do decide to look at the graph from -1 until I'm going to go to 5, and then, oh, my y's were all over the place, so I'm just going to go from, we'll go -5, oh, try to go from -5 to maybe 5, counting by 1s. That must have all been left over from a previous problem. Okay, so remember I picked my window strategically for my x-axis because I knew I'm only supposed to look between time 0 and 3.5 anyway. So this is a pretty good picture of what's happening. All right, part A says to find the acceleration at time t equals 3. So what I'm looking for is a of 3 is equal to something. Well, how do I find acceleration if I know velocity? A of 3 is the same thing as v prime of 3, and v prime of 3 I can find on my calculator. So we're going to go math 8 for n derive. I'm going to take the derivative with respect to x of alpha trace y1, so I don't have to retype things in, and I need that only at 3. So -2.118. -2.118. And there are no units given here, nor does it ask for them. So that's it. We found the acceleration of the particle at time t equals 3. Notice you can't just write this number, you've got to give it a label. Okay, make sure you tell the reader what you are actually finding. Okay, my pen will work. There we go. Part B, find the position of the particle at time t equals 3. So I want to know x of 3 equals something. Well, how do I find position if I know velocity? Hopefully you're saying I need the antiderivative. So x at time 3 will be equal to wherever I start plus the collection of all of my changes over the time that I am moving. Okay, so that's how we show the AP readers what we're finding. Again, where we end up is equal to where we start plus a collection of all of our changes. So x of 3 is what I want to find. X of 0 is -5. That was where I was starting 5 miles or 5 units to the left of whatever I was finding, or whatever I was referencing. This then, the integral from 0 to 3, I have my calculator, so math 9 for f int, from 0 till 3 of alpha trace y1, right, because I want the displacement, so I'm using this integral. This on its own is 3.2398. 3.2398. And so my position at time 3 will be equal to that plus my -5 starting, -1.760. Okay, so there's my position at time equals 3. Also, if you wanted to, on your calculator, you could actually go to your graph and you could do second calculate, so second trace, and use this integral right here, number 7, going from 0 until 3. And it'll actually shade the region for you so you can see what you're really finding. Okay? Let's see what part C says. Evaluate from 0 to 3.5 v of t and 0 to 3.5 the absolute value of v of t. Interpret the meaning of each integral in the context of the problem. So remember, context means you have to reference the story that's being told. So I'm going to start with finding the integral from 0 to 3.5 of v of t dt. I'm just going to do that with my calculator. So math 9, 0 to 3.5, alpha trace y1 with respect to x. Uh-oh, I didn't move over far enough. Yeah, calculator got mad at me. All right, I get 2.844. Then I'm going to go through, so that was this one. Then I'm going to go through and I'm going to find the integral from 0 to 3.5, the absolute value of v of t dt. So we can do that in our calculator also using math 9, 0 to 3.5. And then the easiest way to get to absolute value, you can go to math and then numbers, but I just do second 0 because that gets me my catalog, and absolute value is the first thing there. So I want the absolute value of my velocity function. And dx, I get calculator's thinking about it, 3.737. All right, so we integrate just velocity, we get displacement. So 2.844 is the displacement. Now that's the mathematical reference, but what are we displacing? It's the displacement of the particle from time 0 to time 3.5, right? Because we got to talk about in context of the problem. 3.737 then, if we take the absolute value of velocity, we've now taken away the direction. So now I'm getting credit for every mile that I run, right? So it doesn't matter if I was running to the right or to the left, I still get credit for that. I'm not talking about where did I end up. I'm talking about what was my total distance traveled. So 3.737 is the total distance traveled by the particle from t equals 0 to t equals 3.5. My pen is really slow, so I didn't write out the word time. That looks like Durden's total distance traveled. Okay, so again, no absolute value bars on velocity. We just get the displacement because anytime I move left, it's counting me as negative, whereas the one in red gets me my total distance traveled because I'm getting credit for everything. All right, a second particle moves along the x-axis with a position given by this guy. At what time are the two particles moving with the same velocity? So I want to know, where is the velocity of the first particle equal to the velocity of the second particle? Well, the velocity of the first particle is just v of t, right? That was given to us. And I want to know where that's equal to. If I have position here, then my v2 of t, the velocity of the second particle, is going to just be the derivative. So 2t minus 1. So in my calculator, I already have my velocity, v of t, in there. So I'm going to do 2t minus 1. And I'm going to graph these two things. And I want to know where they are equal. So I'm going to go second trace. I'm going to figure out where these things intersect. First curve is blue, second curve is red. Looks like it's happening at 1.5. Make my guess. Close, 1.571. The particles have the same velocity. Okay, so again, showing kind of a general setup for each one of these situations and then saying, well, what is the velocity of the first particle? It's that whole sine function. What is the velocity of the second particle? It's going to be the derivative of the position that's given here. All right, then for yours to try is 2013, question number 2. Okay, looks very similar, things to think about. Make sure you store stuff in your calculator as you are using it and score yourself according to the rubric.